In this video, we're going to look at the proof of the derivative of the sine of x. Graphically, we showed that this derivative of the sine of x is the cosine of x. We're going to use the limit definition. The limit as h approaches 0 of sine of x plus h minus sine of x all over h. Recall that the sine of a plus b is the sine of a cosine of b plus the sine of b times the cosine of a. We're going to need to use that when we expand this first step. So we're going to have the limit as h approaches 0 of sine of x times cosine of h plus sine of h times cosine of x minus sine of x all over h. Okay, we're going to do a little rearranging and factoring of the numerator. And I'm going to say the limit as h approaches 0 of the sine of h times the cosine of x all over h plus the sine of x times 1 minus cosine of h all over h. So a couple things happened here. Number one is I rearranged so that these two terms were grouped together and factored. That's the second fraction here. And the second thing is the sum of the fractions can be rewritten. So here I have the sum of two fractions with the common denominator h. Okay, we are taking the limit of this whole quantity, and we need to recall a couple other limits. The limit as h approaches 0 of the sine of h over h. Also the limit as h approaches 0 of 1 minus cosine of h over h. Okay. The first limit here is 1, and this limit is 0. All right, we're going to use both of those as we evaluate this limit. So remember, the limit of a product is the product of the limits. Oops, that should be an h. So I'm breaking up each of these fractions into their products. All right, and we are going to let h go to 0. So the limit of sine of h over h as h goes to 0 is 1. The limit of the cosine of x as h goes to 0, this does not have an h in it, so its limit is the cosine of x. The limit of the sine of x as h goes to 0 is the sine of x. And the limit of 1 minus cosine h over h is 0. When we simplify, we get the derivative is the cosine of x. All right, we're also going to take a look at the proof of the derivative of cosine of x, which is negative sine of x. Again, we're going to recall the cosine of the sum. The cosine of a plus b is the cosine of a times the cosine of b, minus the sine of a times the sine of b. So again, we're going to use that. This will be very much like the derivative of the sine of x. We're going to use that to expand the cosine of x plus h into the cosine of x times the cosine of h minus the sine of x times the sine of h minus the cosine of x. We'll do some similar algebraic rearrangement and breaking up of the fractions. I'm going to do negative sine of x times sine of h. Oops. Over h plus cosine of x times cosine of h minus 1 over h. We're going to take the limit of each of these fractions as h goes to 0. And I'm going to break that up into the limit of the product into the product of the limits. Oh, let me rewrite that. Okay. Taking each limit, the limit of negative sine of x is negative sine of x. The limit of sine of h over h is 1. The limit of cosine of x as h approaches 0 is the cosine of x. And the limit of cosine of h minus 1 divided by h is 0. So we get the derivative of the cosine of x is negative sine x. All right. I think there were a couple other derivatives to prove, but I'll save that for another video.